Why does preset veryfast in FFmpeg generate the most compressed file compared to all other presets? The FFmpeg wiki says that the best compression rate is by preset veryfast. But when I am trying it with my video, then preset veryfast provides the best compression in my case. The following is the output of my samples. Preset ultrafast. Preset superfast. Preset veryfast. Preset fast. Preset medium. Preset slow. Preset slower. Preset veryfast. Why does preset veryfast generate the most compressed file compared to other presets? And is the video loss something with preset veryfast?
Lossy compression is a trade-off between bitrate, file size, and quality, not just about getting the smallest files. If that's all you wanted, use preset veryfast CRF51, and optionally downscale to 256 by 144, to get a very tiny file that's mostly just blurred blobs with no detail. Encoding is a three-way trade-off of CPU time against quality against bitrate, very different from lossless compression like zip, where file size is how you measure best compression, and is what you trade off versus time in a two-way trade-off. One or three-way of compression and decompression speed are independent. Preset veryfast gives you the best trade-off X264 can offer too, by spending more CPU time searching for ways to represent more detail per bit, i.e. best trade-off of rate per distortion. This is mostly orthogonal to rate control, which decides how many total bits to spend. X264's default rate control is CRF23, FFmpeg CRF23. If you want smaller files, use preset veryfast CRF26, or something to spend fewer bits for the same complexity, resulting in more blurring. It's logarithmic, so bumping up the CRF by a few numbers can change the bitrate by a factor of 2. For nearly transparent quality, CRF 18 or 20 is often good, but costs more bitrate. CRF mode is not true constant quality, SIM, PSNR, or any other metric. With faster encoding presets, X264 uses a simpler decision-making process to decide where to spend bits, resulting in some variation in bitrate for the same CRF setting. With different search tools to find redundancy, as Atsopmari explains, a higher preset might find a much smaller way to encode something that only looks slightly worse, or a way to encode some blocks that looks much better but is only slightly larger. Depending which way these things go, on average, the same CRF at different quality presets will have different quality and different bitrate. That's why you don't get progressively smaller files at identical quality. Preset veryfast typically looks worse at the same CRF. Preset ultrafast is usually noticeably bad even at high bitrate, low CRF, but other presets can look as good as verySlow if you spend much more bitrate. Smaller file doesn't mean better compression. Remember that quality is also variable. If you used FFmpeg in.mp4 sim1 tune sim preset verySlow out.mkv to get lib 264 to calculate the sim visual quality metric, you'll find that verySlow has better quality per bitrate than veryfast. If you're benchmarking quality, do it at fixed bitrate, i.e. 2pas not CRF. See this URL. Keep in mind that psychovisual optimizations that make images look better to humans, like PsyRD equals 1.0 column 0.15, can score worse on some quality metrics, so for real use you don't want TuneSim. PsyROAD means to take human perception into account when optimizing the rate versus distortion trade-off. AC, adaptive quantization, is another Psy optimization, but one that sim is sophisticated enough to recognize as beneficial, unlike the simpler PSNR quality metric. Humans tend to perceive high, spatial, frequency noise as detail if it's small scale, even if it's not the same detail as in the source image. And our eyes like detail instead of blurring. For example, fringing and ringing artifacts from quantizing equals rounding the DCT coefficients can actually look better than just blurring everything, if they're minor. Stuff that looks worse when you pause and zoom in can trick your eye pleasantly when you just watch normally. H.264 has a deblocking filter in loop, applied before frames are displayed and used as references, so it more easily avoids blocking than earlier codecs like DivX, H.263. Cranking that up can just blur everything at low bitrate. The idea here is similar to what MP3 and other advanced audio codecs do for sound, except there's more room for psychoacoustic optimization because loud sounds really stop ears from hearing quiet stuff at nearby frequencies. If you're encoding once to keep the result for a long time, and/or serve it up over the internet, use preset verySlow. Or at least, preset medium. You pay the CPU cost once, and reap the savings in file size, for a given quality, repeatedly. But if you're only going to watch and encode once, for example to put a video on a mobile device where you'll watch it once then delete it, then preset faster CRF20 makes sense if you have the storage space. Just spend extra bits. Footnote 1. In lossless compression, you trade off file size versus speed of compression and/or decompression, which can be different. Some codecs are very fast to decompress even if they allow good slow compression. Actually, RAM usage, cache footprint can also be a variable if you want to get into that level of detail. In lossless compression, quality is fixed at perfect, like X264, QP0. H.264 decode performance can vary, some with number of reference frames, more having a larger memory footprint and thus maybe more cache misses for a CPU decoder. But often H.264 is decoded by hardware. As with many lossless compression schemes, big changes in decode performance are only had with totally different codecs, like H.265, not different options for the same codec. Extra encode time is spent searching for different ways to encode the same bits, but there's only one way to decode. And yes, H.264 has a lossless mode, as part of the high 444 pp profile. No, you don't want to use it over the internet. Many decoders other than FFmpeg lack support for that special feature, and the bitrate is enormous, like 100 to 200 Mbit/s for 1080p 30U4:2:0 or RGB 4:4:4. How to create an uncompressed AVI from a series of 1000s of ping images using FFmpeg has some test results from the Sintel trailer. Footnote 2. Other codecs like H.265, with the X265 encoder, or VP9 can offer even better rate distortion trade-offs, but at the cost of much more CPU time to encode. For a fixed encode time, I'm not sure if there's any advantage to X265 over X264. But decoder compatibility with H.265 is much less widespread than H.264. Decode compatibility is very good for H.264 main profile, and hopefully also high profile these days. 8x8 DCT is most useful for high resolutions like 1080p and especially 4K, X264's default is high profile. Some obsolete mobile devices might only have hardware decode for H.264 baseline profile, but that's significantly worse quality per bitrate, no B-frames, and no CAVOC, only the less efficient CAVOC for the final step of losslessly encoding structs into a bitstream.
The presets don't control the speed of the encoding. They enable or disable compression features, usually called tools. When using a slower preset, more tools are enabled. But since every video is different, it's impossible to get the balance perfect for every video every time. In the case of your specific content, one of those tools is taking more CPU and more bits, but it will generate higher quality video while still fitting inside the bitrate envelope.
FFmpeg.